Very kind introduction. It's right. I did switch 3 years into a 6-year PhD. So if anyone ever wants to make an enormous leap, I have in the past served as a resource, and I'm happy to again. But today, at least for the formal part of our interaction, I'm here to talk about systems for helping people form ideas about what they want to do, a better understanding of the world, and how they want to act on it, and how they communicate that to others, especially if that other is a computer rather than another human being. I also want to just acknowledge the generous funding of course, Harvard and the Harvard Radcliffe Institute, which supported me over the last year, and of course, the NSF, for which much of this work would not have happened. So let's, I think it's so beautiful that Michael mentioned that I started in HCI thinking about large classrooms, because I actually, in reflecting on what I wanted to share with you today, I came all the way back to that kind of origin story of why was I doing human-computer interaction. I was a teaching fellow in a massive undergraduate computer architecture class where people were producing pages and pages of esoteric code that was only in that class. The professor had invented the language that was unreadable 30 years ago, and we were still using it. And so I, as a TF, would go from student to student and just be like, there's not the right division of labor here. I can't look at these pages of code and know what's going on. The computer could look at it, right? If only the computer could help me have a better awareness of all the different design choices that are being populated by all these students, such that I could have the kinds of conversations that only I, as a TF, as a human, can have with them. So, for example, we found that students were constructing Turing machines. Most TFs had taken the class before, they had made their Turing machine, and that was the way you made it to satisfy the assignment. And so when they met a student who was making the Turing machine some other way, they'd say, what are you doing? That's wrong. Start over, right? When in reality, there were multiple Turing machines that met the spec. And by analyzing the space of solutions, we were able to tell the TF, we were able to better inform how they would act in the world. And so this notion of kind of helping people act better in the world and understand what they want to do, what conversations they want to have, it comes up again when I'm talking with my collaborators in the medical world, right? I have a collaborator who's in chronic pain management, and he says, yes, there's one of 20 different drugs I could prescribe, but a huge part of it is the relationship with the patient and me helping them understand that given their sensitivities to various prior drugs side effects, that we're having a conversation there. He's almost selling in a good way, helping them consolidate a plan to address their pain with the chosen medication. And computers can help that doctor maybe think about the back, instead of doing mental back of the envelope calculations of like quick pattern matching, oh yeah, this drug worked for this similar person last time, we can help them. So this is the kind of problem that I find really exciting. One last connection here is, when we're thinking about communicating to the computer, or thinking about what kind of, how the computer is playing this role, like I like this particular stock photo because it reminds me that sometimes in our user studies, we found that, like, say, we're asking the user to give examples of what they want, and the computer will try to guess something, program that fulfills what the user in this study wants. And sometimes in that interaction, the user will be like, oh, I got it. I know the regular expression that I want. I can write it down for you right now. But in our interface, because we were so focused on supporting them to get the computer to guess it, that we never had an interface affordance to allow them to write in the answer. We were so focused on the communication to the computer as opposed to, no, what really matters is the person walks away with the thing they need. So I generally think of this as kind of AI-assisted task formulation and/or AI-assisted task completion. So each of my projects, sometimes it's just helping the user have a better understanding of what they want to do. Sometimes it's helping, they have a notion of what they want to do, and the AI is helping them achieve it. Sometimes it's both. And so I actually think about this now more than ever as a conversation. So you can go back to On Language by Herbert Clark from a book by a psychologist, I think emeritus now here at Stanford, a classic on all the minute steps that make conversation between humans work. And so I've been asking myself, well, if you remove the human and introduce some silicon, right, what parts of those little things change? What little interface affordances are possible, or what are additional cognitive tasks that if we're not aware of them, we may design an interface that is subpar. So I am not going, yeah, and by the way, just as a caveat, I know there's some approaches out there in computer science which try to model the context, the opinions, the values, the goals, all that. I am just assuming in all of my work that that is inaccessible and it is a fool's errand to try to guess. So just, not to say that it's not valuable work, but that's not generally what I'm trying to do. So this human AI communication, I am currently kind of accumulating from all of these papers over the years. I'm trying to think about all of these little pieces, all the little details. So I'm going to step you through the details that I've identified so far from these papers. They require kind of controlled user studies to fully, falsifiable hypotheses to test to tell you that these are exactly right. But I'm going to tell you about them in case they spur your thought about what you might look into. And then I'm going to go into detail into our two most recent papers, one that was conditionally accepted on Friday. And that I'll talk about for the first time, so bear with me. Okay, so first thing that I've noticed is, I'll just go real fast. When you're expressing your intent, sometimes you realize as you are expressing it that the intent's not quite what you thought it was, right? So there's intent refinement opportunities at the expression point. If you allow people to provide multiple expressions of their intent, like, oh, I think this constraint is something I care about, but in parallel, also say, actually, there's this other constraint. Maybe that's the one that I care about. Suddenly, if they are not forced to, kind of commit to something, it's much less anxiety-provoking to say, computer, try this, or it's removing the anxiety or the consequences of giving a specification that ends up not being what you want. Parallel program synthesis in the Swage program, this was a huge win to our users. Supporting multiple modalities, if possible, like annotating concrete examples or allowing them, not just kind of saying words or that kind of thing. Extracting and displaying a diversity of examples from data if the data is available, or generating a diversity of examples. So again, from psychology literature, common ground, right? Those examples can be that kind of grounding common ground that reflect what you want and are also observable to the computer, unlike the values that you hold in your mind over your personal values. Also, like showing inferred commands, if possible. Just the simple difference between talking to your Google Home Mini versus Siri on your phone, where you can see the transcription of what it thinks you said, make a huge difference. The system state, the same way that you ask your Google Home Mini in your kitchen to cancel the timer, and it does, but you didn't realize it had two timers, and it canceled the wrong one because it was confidently wrong, because requesting clarifications if the system is uncertain is not foolproof, because it could, all of these issues, again, these are just observations that I've accumulated over working on these projects that I'm sharing with you right now. The integration step, I think that we often, there's been a lot of work, including some of my own, on creating writing assistants. Like, hey, ChatGPT or a large language model can continue my sentence, and maybe that will serve as inspiration for where I want to go. Many of you are probably making use of predictive text in your Gmail. There is non-trivial integration costs that we can think about that have come up, especially when you're doing kind of more creative tasks as opposed to dashing off an email. Or we can, there's a lot of cost in looking over the results of execution. So this is really just the good old gulf of evaluation, right? Flash fill, one of the first program synthesis tools that was commercially available. You could go into Excel and give a couple examples, and it will synthesize an Excel formula that it thinks is what you want, right? And yet it gives you basically no support for looking over thousands and thousands of rows of data, right? So there's all these kind of tasks that are maybe subtle, but that if we don't support them, we are batting below our possible batting average in terms of supporting the quickness and accuracy and fewest number of round trips to get to what we want and have the computer correctly understand it. Finally, with each one of these interactions, person is going to be updating their mental model of the machine, hopefully correctly, and updating their mental model of the world and any relevant data. So I think I put this out here as a living document of as I accumulate and do systems. I think each one of these, if you can take them and go to a new domain and say, what are the implications of this, of supporting this cognitive task in this new domain? And so and if you do that, please tell me about it. I am going to talk about this loop in the context of our most recent paper, PaTAT, which is the pattern-based thematic annotation tool. This work is in collaboration with Toby Lee's lab and led by Simran, but also with the help of Zhang, Xiaohang, and Yihao. And so this is conditionally accepted under the title Human AI Collaborative Qualitative Coding with Explainable Interactive Rule Synthesis. So the backstory, because you can all read the paper eventually, but you can't necessarily get access to kind of like the backstory behind the paper. The small backstory behind this is that I mentioned Flashfill. When I was a postdoc at Berkeley and hired on a program synthesis grant, I was required to do one program synthesis project as an HCI person. I said, I don't know what that is, but I will do it. I highly recommend putting yourself out there like that if you have the opportunity, because it was the hammer I didn't know I needed. Basically, Microsoft had just come out with this toolkit called Prose, where it was like, hey, we have a set of grammars over, say, patterns and strings, right? Or you could give us a grammar, and we will, if you give us examples, we'll synthesize a program to you in that grammar that meets your spec, and given your ranking function, is hopefully what you want. And of course, the devil's in the details in terms of designing that ranking function or designing an interface that supports you recognizing the program you want, given an imperfect ranking function. So I've always wanted to have interactive program synthesis, programs be synthesized over text, but not just the raw text, patterns in raw text, but patterns over parts of speech. That seemed like a much more powerful grammar that they did not have. And so we did it. This is, sorry, it was like, that's the high level thing. I'm extremely excited that the application that we decided to apply this to show its utility is thematic analysis. So thematic analysis in terms of a rich human AI communication problem is one where it's iterative, where the user it requires deep engagement on the part of the user. And there are many different valid outcomes because obviously we talk about iterator reliability, but if anyone's familiar with that paper about like iterator reliability being not always the most important thing, it could even move you away from interesting observations that are less frequent, right? Because you're just focusing on consistency. It's like if you're trying to be consistent, you're actually steering away from the interesting ambiguous stuff that might be a good part of your research. So there's multiple valid outcomes, and the success ultimately is defined by the user's research questions, right? Two different people could have the same data, but have different research questions and have entirely different code books. So it's a really, I think it's a good problem to look at. We did a formative contextual inquiry study with 5 experienced qualitative coders who did coding of their own data and then an interview afterwards. They often did have this hypothesis-driven approach, right? So it kind of validated that the research question is determining a great deal of what their path through the data is, but that the code book does evolve. How many folks have done qualitative coding themselves? So at least half of you. So for that half, this is redundant. For the half that hasn't done it, that's for you. So the themes of interest to a given participant evolve significantly. For every step, they're defining new themes, even though they may be started with an initial formation of their intent, right? You're by definition, this is a situation where that initial intent is going to be wrong, right? We have to have those round trips. Participants wanted and expected the AI to improve and expand their capabilities as long as they had control and leadership. And they tried to understand the rationale behind the coding suggestions, because that was part of what kind of made them decide whether or not to trust it, and also what they could learn from it. Because ultimately, right, the ground truth is in quotes, right? It's a lot of the prior work on adding AI assistance has been optimized for accuracy, not on user takeaways. But the ultimate goal of qualitative coding is not to build a model of the data, or even to produce the annotated data set, right? The goal is to discover the themes that you walk away from that shed light on your research questions. Again, going back to like, you are a better actor in the world because of this assistance, as opposed to getting the computer to do the thing. So the first, the primary design goal here is to optimize our interface and our system design for the user's learning about the patterns of data. So, you can think about this as kind of a two-dimensional space. I mean, obviously, it's a completely made-up curve, and maybe there will be a new technology that just totally, is way off the curve. But for now, right, like generally, these lower transparency methods, like deep neural networks, they're harder to optimize for the user's learning because they are somewhat black box. Whereas if we give up a little bit of accuracy, we can gain a great deal in transparency, and that is a worthwhile trade in our argument if the outcome is not how good your model is at taking additional interview data, but rather for you to understand, the answer to your research question. So with more transparency, it's easier for the user to understand and validate or modify the model directly, right, or indirectly through correcting explanations of the model's decision on an individual piece of data. So pattern rules are really promising in this area. So there's Cody, not our work, from 2 Kais ago, had a code rule engine where it would take your examples and come up with an example of a rule. You can see they're doing kind of some stemming and some logical but it's a very basic language. And then because that's too basic a language, it's not, I'm guessing, it was not powerful enough in terms of accuracy to be useful, that they augment it with kind of a black box machine learning engine. So now you're getting both kind of these recommendations based on the pattern and also recommendations separately from this opaque black box. And so they're kind of trying to have their cake and eat it too. It's terrific work. We went a step further, and we are synthesizing rules from examples like them, but maybe slightly different machinery. But we're using a regular expression grammar over parts of speech, entities, literals, like just a particular word, stems of words, wildcards, and semantic soft matches, where something is price. This is where you could technically call it neurosymbolic, which is all the rage today, where say synonyms as identified by a large language model, but not kind of an opaque way, right? Not just kind of like we have an interface where you can look at what were matched under the notion of synonym. By the way, if anyone has a question, I am very open to being interrupted. Just so you know. And I also just want to point out that traditional human-in-the-loop or interactive machine learning approaches, they are often, they're not really built for iteration. They're built for I know what a dog is. It's very unambiguous. You ask me to create a classifier for dog. You give me labels. I predict the rest of the dogs. And that's not the process here. So you can see, part of the interface here, it's built for iteration. It has this, you have the ability to rename, give a different names for the concept that you're iterating on, merge, split, or remove these sets of kind of this multi-classifier system that is, in this case, what you're seeing. Sorry, I realized I skipped over kind of exactly what the model was. You can see here, this is basically a linear combination, the classifier output is a linear model over these kind of high enough F-score regular expressions over that grammar that I described. And you can see over the left-hand side, for each piece, document or piece of data that you would label, the predicted, if there's a prediction, the label, and also an explicit, like what part matched one of the patterns. You could also promote a pattern that was not selected to be used as part of this linear match. We basically figured that, again, this balance between accuracy and transparency, up to 5 regular expression rules with a linear combination of them, we felt like that was as complex as we were willing to go to get accuracy, but not lose kind of the ability for the human to kind of reason and have an accurate mental model of what the model is doing on the data. Oh, yes?
Question. So for the predicted price, so are you essentially adding the labels of what you think should be valid codes for this, and they're finding them? Or are they looking at the data, seeing similarities, and suggesting a code?
Right, okay. It's like, if this is a mixed initiative system, who's taking the first initiative? Or like, how much initiative can the computer take? The computer does not suggest codes. It is the conversation, because again, thinking of that loop, the human still has their own internal research question that the computer doesn't know anything about. They will give a couple examples, and that's what kicks off the response. And then back and forth.
Just a follow-up on that, actually. In that loop, if I just select 10% coupon, is that enough for it to generalize? Or like how many examples do I need to give for this thing to kick off, roughly?
Gosh, that's a really great question. I think it's, I don't know if we start generating patterns for a single example. It may be 2 or 3, but I'll have to check with Simrit.
But it's a small number.
It's very small, right. This is few shot learning, right? Not 0 shot, but few shot. And so what's really nice, actually, and it's not shown in the screenshot, but it's shown in like 2 slides, is that once you have these kind of patterns over the data, you can reorder these based on kind of the kind of certainty, or like you could group them by which pattern of the patterns in the model they satisfy. So you could look at there's various ways that you can leverage those patterns to kind of show people groups. And then also, if something is marked wrong, right, you can look at why it's marked wrong, and you can annotate on the piece of code not only like, is this wrong, and here's the right label, but here's the part of it that you should be looking at, where a human would look that maybe a future pattern should satisfy. And you can also see when it's right for the wrong reason, and then say, yeah, it is about price, but not because you highlighted the date, because of this word over here instead. And that will, of course, trigger a recomputation of the patterns that best fit and the linear model over them. Yes?
Follow-up. So, like, let's say that there was a person who did not mention price, and it was not about price at all. Is that going to cause a problem? Are they expecting that pattern to show up in every single one of the participants? Or
no, right. So this, see that theme drop down? The person, in thematic analysis, you're often going to come up with multiple, yes. So you can choose to work on, you could create a new theme, you could switch between themes that you're working on.
Yeah, well, I'm saying right there, it says predicted not price.
Yes. When you select one theme, you're basically looking at one theme at a time. You can still, I think, add labels for other themes, but you're looking at all the data.
Okay.
It's just,
does it exist in there or not?
It's just, is it, price or not, and you can kind of group them in different ways.
Okay.
Yeah. It's actually quite, it's a tough system. I think all the details will not be able to come out in this talk, but I hope that you'll look at the camera ready too. So this is, the user can understand and validate or modify the model directly, right? They can like remove or promote various regular expressions to be included kind of forcefully. They can also indirectly correct just by annotating additional examples or correcting what parts of those examples are the part that you're telling the computer to focus on. So if you're looking at kind of the entire architecture, you have the user starts annotating data over there at 1. PaTAT learns the pattern of users' annotations and synthesizes rules based over the grammar. It selects a set of rules that can capture the broadest, kind of some notion of coverage and quality, not labeling things that the person has already explicitly labeled as something else. And then the user can kind of group and rank the data on the left-hand side based on these different possible grouping modes and ranking methods, like show me the things that it's most confident about, or show me the things it's least confident about. And then also, these modifications as you kind of iterate on the code book. So you can see here, sorry, it's very small. But you can see a little bit of, this is an example of how you can look at things grouped by similarity from a kind of a BERT standpoint. You have, let's see, you have a pattern filter, so you can look at all the sentences that matched a particular regex within the model, either one that's within the model already or one that's kind of in the wings, waiting to be promoted potentially. So you can, it's highlighting the piece that was the reason that it matched the pattern in every one of those examples in blue. So that can make it, we're just looking at are there different ways to even just help people speed up consuming the recommendations. And so they can also, as you can see here, right, they can see when they look at that blue highlight, the pattern that it matched and what that pattern was. They can tell system that wasn't the right pattern. They can split, so price might actually be two subtly different categories, like price and money, and then author kind of two models out of the original one. And this is my favorite, because this is the part that makes it neurosymbolic, but is still intelligible or legible. Because I really hate when the system is just and then it magically does something and I'll never know why. This is showing all the things in the data that were considered with respect to the large language model similar enough, right? These are kind of the synonyms, right? So I know I can go through, and for each one of these, if I want, right, for that soft match, I can say, oh, that is a misunderstanding of that word, right? Or in this context, that's not a synonym, even though on average it usually is. And I can explicitly say, never match those two in this context. And so there's just really a level of control and legibility that I look for in every one of my systems that has a neuro part of the symbolic. Yes?
Yeah, I have a question about looking at the patterns, I guess, from someone who's doing coding. So I look at this model that sees all these weights. How am I supposed to interpret that? Am I supposed to say this regular expression is more important than another, or is it supposed to just help me?
That's a great question.
Yeah.
I mean, I think strictly speaking, saying that, and when you have so 0.9, the weight on num or soft match on expensive for this notion of price, you could, say, and also it's not clear to me that these weights are actually normalized. I did not read, in terms of discussions with the lead student and our write-up, there was very little discussion of kind of this notion of focusing more on one thing versus another. It's a think of it as soft information, okay, right? But you can click on that filter, say for prop n or ordinal, right, with a minus 0.02, it's almost never factors in and very little bit, and kind of you can click on that and say, what is matching here, right? And then you can kind of debug from there. Maybe it's right to have it. It's not. It's again. This is so basic, but we're trying to be expressive enough to be accurate enough to be useful while still maintaining legibility. And it's just this balancing act. I don't think there's any true right answer. Okay, so let's take a look at the evaluation. We had 8 experienced qualitative coders come in. They each spent 2 hours with us. They experienced 3 different conditions on one of 2 data sets. And then we talked to them afterwards about their experience. In each condition, they had 100 unique data points from the same data set. So they were working on the same data set throughout the 2 hours, but they were seeing different data in each condition. It was either restaurant reviews or hate speech. Now, I think the hate speech choice, we flagged that in the informed consent. It was and I think it was filtered such that it was not uncomfortable for our study folks. But it is, I think, important in terms of its ambiguity. I think actually there's someone in the room who's done really great work with D.E. Yang, one of your new professors, on the contextual nature of that, if I remember your work correctly. So I think it's an important task, representative task. So we would give them a research question to do the qualitative coding, and in counterbalance order, they experienced a baseline version of PaTAT without any AI. BERT, so it's a version of PaTAT that only had the black box model, so there's no explanation highlights on items or display of learned patterns. Now, I guess you could have added some sort of like post hoc analysis, I think, but that is the choice that we made here. And then, so also a lot of the strategies that relied on patterns were no longer available as well, though you could do, kind of BERT level semantic grouping. And then, of course, PaTAT with the full features that I told you. So we asked people to rank from first to third, and then kind of showed for the manual condition, it was almost always first place for ease of use and perceived user control. Not too surprising. BERT didn't really win any competition. And then PaTAT was most frequently ranked first place for usefulness and facilitating human learning of data. So given that last one was like the design goal #1, like we can all go home now. But we won't, because I'll tell you a couple other qualitative insights. So in looking over people's comments on their experiences, they felt that understanding, we observed that understanding the current state of the model did contribute to error discovery and repair. So this is maybe less about kind of person's intent changing, but rather recognizing that the computer's interpretation of their intent is incorrect. So participants found user interpretable patterns synthesized for them to be valuable. So, if it is coding for good price, I'm looking for a positive adjective plus a synonym for price or discounts or whatever. When I see that it's on the right track and doing something like that, it makes me more confident in its ability to predict, maybe on data they haven't looked at yet. And its ability to capture things that I may have missed if I were the only one going through the data. So these patterns are interpretable enough that our qualitative coders can leverage them in the way that we wanted. Now, there are some codes, some ideas like atmosphere or discrimination that are more challenging to capture with the grammar over which we are synthesizing patterns. And so for this, you kind of have just naturally lower accuracy of the system. And so in this case, people kind of more just, instead of looking at the patterns as the system is trying to find 5 regular expressions over our grammar that would capture atmosphere, instead people looked at the data, right? So going through the highlighted words was kind of the way that they dealt with that kind of shortcoming of what I think any system ultimately would struggle with. Interpretable patterns also facilitated the discovery of new themes, trends, and connections, right? And this goes back to kind of that human over on the left-hand side of our loop, right? Where, yes, they have an initial intent or initial idea, expectation, but in a real system, especially in thematic analysis, but in many other situations too, acknowledging and facilitating the evolution of what they want is really, really critical. The patterns also captured outliers that help people notice important details and nuanced aspects of the data that help them further refine what they wanted. So one person said, I'm seeing ideas around women coming up with ideas around violence more. They had patterns of different words like language around body parts, near language about women. So if I'm interested in gender and sexuality, if I'm seeing actually more specific language about body parts that we're talking about, this could be useful. This could be a direction to further interrogate the data.
To pull that thread a little bit, does this mean that depending on the support you gave me, it shifted the kinds of themes I was identifying?
Okay, sorry, you are jumping to the next slide. Could I go to, let's see.
Yes. I'm a player.
There's this really, really tricky question that when you go past what the normal controlled user study is, where it's like, hey, your intent is to label price, go, right? And instead you're like, you are to come up with whatever themes, it's much harder to ask, what is the impact of this assistance on where I get, right? And if there is impact, that's not necessarily bad. It's not necessarily good, right? So like it's always kind of like impact agnostic. And so the best thing, I think this is a really tough evaluation challenge for us, because I think we should not be giving people intent. We should be letting them choose their intent so we can better understand the whole loop when we're evaluating our systems. But this is our intent. So what you can see here is the different colored bars correspond to the different conditions. And we kind of just tried to create a linear ordering over the names of codes that came up in any condition so that you could see, like, okay, so here's in PaTAT, BERT, and manual, religion came up, and that was like kind of like, but you can see there's some variation in how many things were tagged religion. You can see in PaTAT and manual, both identified gender. Sexuality, you could argue, is, well, if you're a women's and gender studies thing, it's entirely different, but maybe to our qualitative coders, they thought that was the same thing. Anyway, so you can see that there's some convergence, that there maybe are, like, I don't want to say, look, the system got you where you were going to get if you were just doing it manually. I can't say that. But this is the best picture I could give you at the moment with the kind of the evaluation that we have to say that, I mean, you can definitely see things like service showed up immensely in BERT. BERT was like, service, this is a thing. You should tag it, right? And people responded to that by tagging it. And that didn't seem to come up as much as like an idea in the manual and the PaTAT, right? And so like, I think you're seeing some divergence in what people call out, but I can't say if it's good or bad. Does that answer your question?
Yeah, I don't even care about good or bad. It's just fascinating to think about how it shapes my thinking, right? What does it guide me toward?
Even the default initial ordering of the data is something that could shape where you ultimately go. Mm-hmm. Yes?
So I'm not sure if this is a great question, but I'm just curious. So I suppose like when you're using a technology like this that like helps with coding like faster or more efficiently, I would wonder kind of like how if the PaTAT like helps also like assessing like significance of like the resulting codes that you might come up with. Like for instance, like if you're able to now try out a whole bunch of different codes, right? There's like also this risk that maybe you find one in particular that's interesting.
Yeah.
But you've also tried like 50 now, whereas like before maybe you only tried like a couple.
Oh, I see what you're saying. Basically, like it's not so much amplifying your effort in terms of like, oh, it's pre-digested all these additional things that you might also code with that same thing, right? Kind of like a longitudinal thing. You're saying it's kind of amplifying your exploration of the data because it makes it easier to go wide.
Yeah, I'm just asking like maybe if that's.
I hadn't thought about that at all. It's a great question. I mean, my gut would say that yes, like, the same way that like in traditional interactive machine learning, like with every additional annotation I give, if I change my mind later, I have to like redo my work. It's not really, facilitating evolution. I think that PaTAT is designed to facilitate evolution, so I think maybe people are less inhibited to, let me create a new thing. If later it converges the same thing I have some patterns for over there, I can literally merge them. Yes?
This is an interesting question, but you were talking about how it does diverge. I did it manually versus I used PaTAT. I'm curious, based on from the AI behind, where some of it is more and some of it it's like, some of it is more transparent and some of it isn't. If I did it versus if you did it, would there be a difference in what codes that we see? Because if we annotated differently, the odds of us having a different code,
well, the odds of you having the same set of models, yes, you might come up with different codes. And even if you came up with the same name, with the same kind of underlying intended meaning, you might, given you gave slightly different examples from the data set, have different models that would predict that code on future data. So I guess one interesting graph to kind of remake here, or to make anew, would be to break this down by, there's unfortunately only 8 people in this study, but to see, how much variation.
I'm asking because like one of the, I guess, issues when it comes to experimental methods is like people decide to analyze data differently, and so as a result, how well can you trust what happened? Because even
Right.
as good as researchers that we are,
Right.
we have these biases and we decided to analyze it in this way. So
Yeah.
is it really significant, or did we just happen to have a leaning in this way?
Yeah.
So
Yeah.
I'm curious if this could.
I think that PaTAT is, the goal with PaTAT is to like facilitate you being you. And because you being you and Jim being Jim are different people, each with your own internal kind of values and research questions or observations that you think are slightly more interesting. Like, I think the system is not going to necessarily, like, there's nothing here that I think would drive you, like, would make you converge. That's a problem with qualitative coding, and I shouldn't even say a problem. It's just how it is, and it's a beautiful thing. It's a little antithetical to how we often like to operate in the sciences, but it's an important tool. And we kind of have to trust the people who are doing it to be aware of, so great question. Though I will caveat on what I said like, oh, it's probably not going to drive you to converge. I don't know that about like if it was BERT, and with PaTAT, like I said earlier, there are certain ideas that are easier to capture with PaTAT. And maybe that's something that would be a place where people would kind of converge on things that were easier to capture rather than more amorphous like atmosphere or discrimination. Okay, so I'll just point out to wrap up this section, and oh my goodness, such great questions. So just point out that like having the data that's annotated with the parts of the pattern that matched it, and having the programs visible, both those things together, it's common ground, right? The same thing that helps us effectively communicate one idea to another human helps us communicate it with the AI and feel that we know that it was communicated. So having both the data and the written programs is really helpful to help refine both the concept in the user's mind and the task that they want the computer to do for them. It's really great. I'm sorry, I'm such a using language fan here. Herbert Clark is my hero. Common ground is the foundation of all joint actions, essential to the creation of the speaker's meaning and addressee's understanding. So with that, I'll come back to our kind of accumulating with details loop here, and kind of use this as a segue to say, okay, let's think about, that was exciting because AI was helping us, and that's kind of like all the rage. Let's just really quickly talk about systems that are near and dear to my heart, where there is no automation. I'm just helping you figure out what you want more than maybe you would otherwise be able to. And I'm just going to go through this really quickly. This was just presented at WIST. The system's called Paralib, kind of like parallel libraries for comparison. And the title of the paper is Concept Annotated Examples for Library Comparison. And so basically, it's that most programmers have to make library decisions, and when they are trying to do something, there's many different libraries that have very similar but slightly distinct operations. Can we help you formulate what you want to do, given this landscape? Can we augment the existing landscape of information about what's out there that includes these kind of summarizing lists, these high-level stuff? We looked at the literature in terms of what people are, what kind of needs for understanding what's out there that maybe these prior, the current websites have, and like fit for purpose, size, complexity, usability. I think my argument is that they're easier, some of these things are easier to assess just looking at the code itself. And like, oh my God, D3, whew, that's gonna take me a page of code and it's gonna take me 5 lines in Vega. Like, but Vega can't do X, right? Anyway, looking at the code, I think for programmers can be really helpful, more helpful than just, beautiful visualizations. SVG. So the problem is that if you are only looking at a couple examples of code, which is typically all we have, generalizing from only a couple examples could lead you astray. That would be overfitting in a human sense. What if we, if we could show them a bunch of examples, maybe they would be less likely to make incorrect generalizations, but it's really hard to compare multiple, many examples at once. So let's, and the reason why I'm really excited about telling you about this paper is because I think there's exciting design implications of these theories of human concept learning that you too could borrow. There's 2 that I want to tell you about really quickly. The first one is variation theory. Variation theory says, and I'm summarizing here deeply, so apologies to Ferenc Martin, but showing sets of many examples in parallel that vary along either a critical or superficial dimension of variation helps humans identify those dimensions as a useful coordinate space to describe the concept that the examples are drawn from. I realize I just read that slide off to you. I'm doing that because these are not his words. This is my best way to translate what he's saying into the language that we use as best I can. You could think, like if an alien came to Earth and he said, "What's a computer?" And I could say, "Well, these are all computers." Right? I'm showing him a set of parallel examples that vary in color, but color is a dimension of variation that exists for computers, but does not define, is not part of defining the boundary, right? But you can do that kind of over and over again to help people come up with the correct generalizations, right? It can help learners develop more robust, accurate inferences about what dimensions and values within those dimensions are and aren't critical to defining the boundaries of what is of a concept and what's contained within it. The second theory of human concept learning that is relevant is analogical learning theory, Gentner's work, and of course all her students and her collaborators, and I mean she, one of the originators, but not the only person working on it, highlighting analogical dimensions across examples, kind of like the head of this dog and this cat, right? It can help people. Obviously, it's obvious to us as fellow mammals that those are the dimensions of that those are aspects of mammals. But for code examples, it's not obvious if you're new. So basically, our hypothesis was that if we annotated common aspects of many code examples side by side, kind of the joining of variation theory and analogical learning theory in the context of code examples, that could facilitate programmers' library comparison at the code level. So basically, we because this is actually a tech probe as opposed to a fully functioning system, so it's just kind of the, we hallucinate that we have these kind of expert annotated concepts. Sorry, I'm using concepts and aspects interchangeably now, which is very confusing. Bear with me. But creating a legend, binding data, we can highlight where that happens in the code across multiple different libraries to help you see the correspondences and the distinctions. So you could call this concept or aspect annotated code examples. So we wanted to help people inspect those concrete code examples, compare functionalities and their associated syntax, help them assess how easy it is to use each library, anticipate how much code they'd need to write, and all that kind of, and also typicality, right? Like what is this code typically looking like? This is our interface. It's really tough to look at. I am actually going to deviate from the plan and say, this is a paper I invite you to read. If this is exciting to you, what I really wanted to tell you about was those theories of human concept learning, because short answer, this helped people make more consistent decisions that were appropriate for their task, and it helped them recognize Recharts uses the same syntax as React, and I tried React last year. I hated it, right? But this other one uses it builds on. It's a library within some library that's more familiar to me or I'm more comfortable with. Anyway, but these theories of human concept learning are incredibly powerful, right? We want to work with human cognition, so I recommend those if you want to start in a good place, a good initial place. In terms of how you help people make sense of lots of data, going back to how Michael introduced me in the beginning, because I'm still trying to do that to this day. The final point I want to make is just a very quick this is a, yes, it's the best paper, yay. At IUI 2020 in March in Italy. It did not happen, but. The title really says it all. And by the way, this is work led by Zana Bochinska and Phoebe Lin, who were Christoph's and my students respectively the summer before. They did incredible work. What they found they had I tell this to you as a warning. They looked at a very toy example. I'll just tell you the setup real quick so you understand it. They they looked at a proxy task. This was Mechanical Turk, but a proxy task of examples to explain what the AI might be looking at when deciding how much fat content is in it. And so the proxy task is trying to predict what the AI would do based on either examples or some sort of kind of deductive description of the contents, right? So this is not, the actual task would be deciding for yourself with the AI's assistance, right? So this is the non-proxy task with the same kind of inductive and deductive possible explanations where you're deciding, you're not simulating the AI, you're deciding for yourself with an AI's recommendation. What we found is that when you gave people not the actual task that they would do in the real world to test the value of inductive versus deductive explanations, you found that people preferred the inductive explanation and didn't prefer the deductive. But when you had them actually do the AI-assisted task where they're making the decision, suddenly their preferences switch, but the thing they didn't prefer is where they did better. And so if we had relied, again, as the title implies, if we had relied on the proxy task, we might have gotten kind of misleading signals about where to invest our time. Now, you can get a table like that in pretty much any study and say, so the reason why I feel comfortable kind of like saying like, hey, this is really important to share with you is because I'm seeing this again in our more recent work on Copilot, right? So Copilot used large language models to predict the next code that you might write. When we had a kind of like a sorry, let's see. When I gave them a fake task, and we compared kind of like a standard kind of just deterministic recommender versus the AI-generated code, they over-relied on the AI, they rabbit-holed. Some of them finished really quickly, and those that didn't finish really quickly ran out of time and never finished because they were debugging code that had been, was rehashed to other people's code that they didn't understand, okay? But when we actually had them bring in their own projects and did contextual inquiry, they no longer did this problematic over-reliance. They had appropriate reliance. They validated everything that the AI recommended, and they wanted explanations. So the design recommendations for what to do to support people in receiving AI-recommended code is very different between the kind of like, we fix the intent and we get that external validity. So is this just, my final thought, encouragement to you as fellow researchers is, if we keep getting these kind of like reversals when we look at a controlled study in the lab and our contextual inquiry, I feel very uncomfortable. I think that given that we've talked about so many times now that this is a loop, that every time we evaluate a system where we don't allow people to loop through and change their intent, right? That we fix the intent. We say this is a controlled study. You are trying to implement dynamic programming. Go. Right, like that we may be potentially misleading ourselves in the evaluation and in the where we put our time in developing better tools. So I will end there and welcome any additional questions. Thank you.
Yeah, we have time for a couple questions.
Do you plan to put the PaTAT open GitHub or something?
I'm sorry?
The PaTAT, the first one, is open?
PaTAT?
Yeah, PaTAT.
Oh, sorry.
You're planning to put it on live, available, or GitHub or something?
That would be lovely. Simra is kind of she's the lead graduate student, and I think I will encourage her to do that. Toby and I and another collaborator are hoping to request more money from the NSF and maybe implement some of those ideas into already existing open frameworks that have been funded in part by IBM for this kind of qualitative coding. So I hope that the features, if not the system itself, the features will become publicly available through other means.
Hi, thank you. For your late-breaking work, do you have like a hunch as to why you saw that switch? Is it because people were people behaving differently?
Yes.
But why? I guess
My hunch is that it's stakes. Oops. So I'm doing some follow-up work with one of my newer graduate students where it's like, okay, if you're programming on something that I gave to you that you're going to walk away from and never be troubled by again, you will be, I don't want to say lazy. You're going to conserve your mental energy, okay, to say it a little nicer. But when it's something that really affects you, right? Or maybe I'm interacting with a generative model, and is that art going to go up on my wall? Or am I going to walk away at the end of the study and be like, well, that was fun. I got $15. I think that I think we need to kind of, I don't want to say raise the stakes in an uncomfortable way, but find stakes that are meaningful, because I think that that's going to help us recognize that people are being appropriately reliant when the stakes are meaningful, and not kind of get kind of over concerned about over reliance we see in situations that are actually quite unrealistic. Yes.
Oh, I kind of wanted to follow up on this. So I'm curious, if you could expand on maybe design choices you might think could help with stakes. So I'm thinking of money, right? But that's not really a practical solution. But you were kind of thinking about bringing in actual projects,
Yes,
maybe,
right.
or do you have other ones? Maybe.
Good old-fashioned contextual inquiry, I think, is the place to start. There's one other thing that I'm experimenting with right now, which is to, we care. We are members of society. We care about what other people think of us. And I think that we can leverage relationships in a non-threatening way. Right? So I'll give you an example. This is very outside of what I normally do, but having someone, we say hey, if you like this, your goal is to come up with something funny to share with a friend, right? Who are you hoping to share this with? Okay, in the next 15 minutes, if you get to something you say you're happy enough with, you open up your email and you email it to them. If you're not willing to email it to them, it's not good enough yet. Keep going until, if we run out of time, we run out of time. There's no compulsion. We're not compelling them to share something with a friend. But by having them do that it makes it real. It's well, that friend's going to ask you, why did you send me that thing? What was that about? You're oh, I was in this study, but it's still, you make it. So, obviously, I don't want to make people uncomfortable, so it's a very delicate balance.
All right. I think we are about at time. So Elena will hang out here for a moment after the talk if you have additional questions. Let's thank our speaker.